Hey everybody, let's transform a quadratic function. If we have a quadratic parent function, which is right here, f of x equals to x squared, if we make any changes to this expression, that's going to affect how it looks graphically. So those changes are called transformations. So the function can be stretched or compressed or just moved somewhere else compared to where it was originally. So when we transform any function, we actually start from a parent function, and then that's our reference. So in our case, we have a parabola which actually goes through the origin and has two branches like that. So it's U-shaped. So that's how it starts. That's how the parent function looks like and where it is located. And now if we, let's say, put a minus in front, like this x squared has a minus in front, what's that going to do is it is going to flip the function reflected over the x-axis. This is our x-axis, this is y. Our parent function, and I'm going to make it dotted, is still right here, right? It's just a big U-looking graph that hits the origin and comes back, right? So if this is our parent function, then if you put a minus, this minus right here in front of it, then what's going to happen is the function is going to reflect over the x-axis. So it's going to end up right here. So this here is our x squared. This x doesn't look too good. X squared. And then this one right here is actually just negative x squared. Now, if we multiply the function by 3, then what's going to happen? It is going to stretch vertically by a factor of 3. So let's say this distance from here to here is going to be 3 times bigger. So it's going to be somewhere up here, right? Actually down here. And that's the case for any other point. So distance from here to here will be 3 times bigger, right? So it will be somewhere over here. Same thing on the other side. So we are going to end up with a graph that looks much more narrow, but it didn't really get more narrow. It actually got more stretched, so it looks as if it is narrow. So it's like we pulled it down in the direction of negative y, right? So this will be, we still have negative x squared because it's the function is flipped, it's opening down right now. And then since we stretched it by a factor of 3, there is a 3 in front of x squared. So that would be this case. Now if we continue, now we can see that this x right here has a 4 added to it. Well, let's actually just change it. No, it's okay. It has a 4 added to it. If it has a number added to x that's under the square, see this whole expression here is under the square, then this number is going to affect x. And it is going to move the function, the graph, along the x-axis this many units, 4 units, in the opposite direction from what the sign says. So it says plus 4, it's actually going to go to the left 4 units. So it moves 1, 2, 3, 4 units here. And I guess I should remove this so we can actually make it look nice. I'll remove this one too. So right now it's actually 1, 2, 3, 4 units this way. So it's actually here. It's still as narrow as it was before. It's still facing down. but now it's starting here at -4. So it's going to come up, hit -4 on X, hit 0 on Y, and come back down. So this one right here is, this here is -3x squared, but now we know that that x got a 4 added to it, right, and then squared. So since x got a 4 added to it, the transformation is on x, but it goes opposite from what the sign said, so it moved to the left. And let's just remember that this one was just -x squared, and then this one was -3x squared. So negative flipped it over, so this one was just x squared, and then negative flipped it over, so it's facing down, and then -3, actually 3, made it 3 times taller or longer along the y-axis, so it's stretched along the y. And then now we have this 5 added to all of it. So this function here gets the 5 added on top of it. That means it is going to go up 5 units, and then I'll just move this here, so this is x squared. So now it's going to go 5 units up, so 1, 2, 3, 4, 5 units. So it's going to be here, and again, now I'll make a solid line because we're actually done. And again, it's going to be facing down, and it's going to be narrow, or narrower than the parent function, right? So now this is our final look of it and final position. So we know that this here, since it moved 5 units up, this is 5, right? So we should be able to see that this is actually -4, 5, the coordinate of the vertex right now. So I hope you might have observed this. What I practically did is I moved the vertex. So vertex is here. When we flipped it over, it didn't go anywhere. When we stretch it, it didn't go anywhere because it's equal to 0. So 0 times anything will really not move it anywhere. But then when we added 4 units on x, the vertex moved here. And then we added 5 units to y, then the vertex moved right here to its final position. So now we have this whole function right here. Okay. I hope you understood the video. I hope you like it. If you did, please come back for more. I appreciate you watching this. Thank you.